Okay, so for this problem here, we're looking at nitrate, and we're going to go ahead and figure out all the different steps, starting with the Lewis dot structure. Nitrogen has 5 valence electrons. Oxygen has 6, and there's 3 of them. So 6 plus 6 plus 6. We also have a -1 charge, which means that we're going to add 1 here. If it were +1, you would subtract 1. So we have a total of 24 valence electrons here. Step 2, this is when we use the octet or the duet rule. The octet rule says that all nonmetals want 8 valence electrons, and the duet rule says that hydrogen wants 2. So we don't have any hydrogens here you have to worry about, so just go ahead and add up 8 for each nitrogen of the 3 oxygens. We get 32. Okay, go ahead and subtract 32, or 24 from 32. We're going to get 8. Divide that by 2, and we calculate that we have 4 bonds here. Okay. I'm going to put nitrogen in the center because we have 1 nitrogen, and I have 3 oxygens here, so I'm going to put them evenly spaced out. Okay. I have 1, 2, 3 bonds, but I'm told I need 4, so let's just go ahead and double that one up here. And then the final step for the Lewis structure is we're going to go in and add in our valence electrons, and we want to add in lone pairs to make it equal out to 8. So I added 4 on the oxygen here because each bond stands for 2 electrons. On the nitrogen in the center, if you go through and you count the bonds, I have 2, 4, 6, 8, so we don't need any more there. I need 6 on each of these oxygens here, or 3 lone pairs. So we have our structure, and I just draw a bracket around it and put a -1 charge. Okay. So from here, now we're going to go and look at what the structure is named for this. And we go back and look at the center, or the central atom. We have nitrogen bonded to 3 atoms, even though we have 4 bonds. And we could also tell that we have 0 lone pairs. Okay, when you go back and look at your chart, which you guys will have memorized for the test on Thursday, we know that this makes it a trigonal planar, okay, which has a 120-degree bond angle. Okay. And then from here, because there are 0 lone pairs, even though we have 3 polar bonds or 4 polar bonds coming out of the nitrogen here, the bonds are evenly spaced out, so all the dipoles cancel out here, and this makes it non-polar. An easy, quick way to tell, again, is with how many lone pairs we have. If it's 0 lone pairs, it's non-polar. Okay. And if it's nonpolar, the intermolecular force that's going to be shown here is going to be a London force. Okay, and that's it for that. On to the next structure, which I'm going to do a little bit quicker. Okay. 5 for each nitrogen, and we have a 6 from the oxygen to give us 16. And then each of these they want 8 valence electrons. Subtract. Oxygen is going to go in the center. I have 2 nitrogens, but we know that we have 4 bonds, so I'm going to double those up. Okay, go in and I'm going to add in my lone pairs. Okay, so there's our structure for dinitrogen monoxide. And from here, let's go ahead and figure out what our structure is. I have 2 atoms that are bonded to my oxygen, and I have 0 lone pairs, okay, which makes this a linear structure. 180-degree bond angle. And again, because I have 0 lone pairs and the 2 things that my oxygen is bonded to are equal, this is going to be nonpolar, which would make this a London force. That's going to be the type of intermolecular force that acts between them. Okay, last one. (12 plus 6). And we have 24 plus 12 to give us 36. Subtract that. 9 bonds. And I'll have to finish this in another video because I'm going to run out of time here. So look at the next